Welcome to Mathematics Online Lectures. Today's topic is triple integral. Again we will discuss about another problem. Problem number 14. Evaluate triple integral dx dy dz by x plus y plus z plus 1 whole cube taken over the volume bounded by the plane x equals to 0, y equals to 0, z equals to 0, x plus y plus z equals to 1. Now, first we will identify the volume by the given planes. Then we will find the limits. Then we will find the integral value. So here three stages. First, identify the given volume region. Then identify the limits. Then third step, evaluation of the integral. Now, in three-dimensional geometry, x-axis, y-axis, z-axis, y is the origin. X equals to 0 is nothing but yz plane. In yz plane, x equals to 0. In this plane, x equals to 0. Y equals to 0 means xz plane. And z equals to 0 means xy plane. So first this plane and this plane and this plane. Now find another one is another plane x plus y plus z plus 1 is nothing but a plane whose intercepts are 1, 1, 1. This is look like x by 1 plus y by 1 plus z by 1 equals to 1. So this is a plane. Here intersection is 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0. A, B, C. Now, if you observe this volume is bounded by backside xz plane, this side yz plane, bottom xy plane, and the circular triangular or plane whose intercepts at ABC. So this is a tetrahedron. The shape of the diagram is a tetrahedron. Inside volume. Now we will find the inside volume. It is very simple. First, this is the region inside the volume. Now, what about the limits? Triple integral dx dy dz by x plus y plus z plus 1 whole cube. Now, what about the x limits, y limits, z limits? So dz, dy, dx, you may take any order, then no problem. X plus y plus z plus 1 whole cube. Now if you observe, x is 0, y is 0, z is 0. So initial limits are zeros. Now from this plane equation, x plus y plus z equals to 1. From this one, z equals to 1 minus x minus y. So what is the meaning? Along z axis, x equals to 0 to this one, this surface, nothing but 1 minus x minus y. After finding the y limits, after finding the z limits, just remove z value, z term. Now y equals to 1 minus x. This is nothing but along y-axis, along this side. So y is 0, initially y is 0, up to this one is 1 minus x. And finally, after finding the y limits, remove y, x equals to 1. So nothing but along x-axis, here x is 0, 0, 0 to 1 only. So this is the procedure for taking limits. First identify the region, then finding the limits, then finally evaluation of the integral. Evaluation of this integral. Now, integrating with respect to z, then integrate with respect to y, then integrate with respect to x. If you integrate with respect to z, other two variables are treated as constant. Here, assume denominator equals to t. X plus y plus z equals to t equals to z plus 1 equals to t. Here z is our variable, other variables are treated as constant. If you differentiate with respect to z, then what happens? dz equals to dt. So now this integral becomes 1 by t cube. This integral only. 1 by t cube integration is integral t power minus 3 dt, that is t power minus 2 by minus 2. So using this methodology, integral x is 0 to 1, y is 0 to 1 minus x. Now integral value is minus 1 by 2 times of t power minus 2 is nothing but 1 by t square. T square means x plus y plus z plus 1 whole square. Now limits 0 to 1 minus x minus y. Now dy dx. Now put z equals to 1 minus x minus y, then z equals to 0, you will get the final expression. Now this is integral x is 0 to 1, y is 0 to 1 minus x. Okay, minus 1 by 2 is common then. Now if you put z equals to 1 minus x minus y, minus x2 plus x both are cancelled. X plus y in place of z 1 minus x minus y plus 1. If you put z equals to 0, 1 by x plus y plus 1 whole square. dy dx. Here x cancel, y cancel, 1 plus 1 is 1 by 2. So this expression is nothing but 1 by 2 times of 1 by 2 minus this term. Minus 1 by 2, x is 0 to 1, integral 1 by 4 is nothing but y by 4 minus, put x plus y plus 1 equals to t, dy equals to dt. Here integrating with respect to y. So now this integral becomes 1 by t square dt is nothing but minus 1 by t. Minus or minus plus 1 by t is nothing but x plus y plus 1. Now limit 0 to 1 minus x dx. Now put y equals to 1 minus x. Minus 1 by 2, integral x is 0 to 1, 1 minus x by 4 plus 1 by x plus y value is 1 minus x plus 1 minus, put y equals to 0, this is 0, y equals to 0, x plus 1 dx. Now after simplification, minus 1 by 2, x is 0 to 1, 1 minus x by 4 plus the x cancel 1 by 2 minus 1 by x plus 1 dx. So integrating with respect to x, minus 1 by 2, this is x by 4 minus x square by 8 plus x by 2. Now x plus 1 equals to t, 1 by integral 1 by t is log t, x plus 1, limit 0 to 1. Put x equals to 1, minus 1 by 2, 1 by 4 minus 1 by 8 plus 1 by 2 minus log 2. If you put x equals to 0, 0. Now minus 1 by 2 times of 1 by 4 minus 1 by 8 plus 1 by 2. 8 is the LCM. 2 times minus 1 times 4 times 6, 5 by 8. 5 by 8. 5 by 8 minus log 2. Now if you simplify, so if you common 8, 1 by 16 times of So 8 log 2 minus 5 into answer. So very simple problem. So similarly, I will give you another problem for homework. First. Now we will discuss another problem. Similar problem. Evaluate triple integral dx dy dz where V is the finite region of the space formed by the planes x equals to 0, y equals to 0, z equals to 0 and 2x plus 3y plus 4z equals to 12. So this is look like our previous problem. 3-dimensional geometry x, y, z, okay. So this is the plane. If you divide it with 12, what happens? This is the given plane. Divide with 12. X by 6 plus y by 4 plus z by 3 equals to 1. X intercept is 6, y intercept is 4, z intercept is 3. So this is a plane which intersect the coordinate axis at 6, 0, 0, at 0, 4, 0, at 0, 0, 3. So plane intersects the coordinate axis at A 6, 0, 0, at B 0, 4, 0, at C 0, 0, 3. This is look like our previous problem. This is look like our previous problem. Now again this is a tetrahedron. Now first, how to take the limits? Very simple procedure. X plus 3y plus 4z equals to 12. Now from this one, what is z? Z equals to 12 minus 2x minus 3y by 4. So solution, triple integral of dx dy dz equals to x limits, y limits, z limits, dx dy dz. Z limit, initially x is 0, y is 0, z is 0. So initial lower limits are 0, z upper limit is 12 minus 2x minus 3y by 4. So from along z axis, lower plane is this one up to this one along this plane equation, this tetrahedron. Now for finding the y limits, very simple method, remove z and find out y value. Y equals to 12 minus 2x by 3. 12 minus 2x by 3. So observe along the y axis from this one to this one. So this is a triangular form. Y equals to 0 to this one. Then finding the x limits 0. This is 0, 0, 0 to along x axis 0 to 6. First integrate with respect to z, then integrate with respect to y, then integrate with respect to x like our previous problem. If you integrate with respect to z, x is 0 to 6, y is 0 to 12 minus 3x by 3. Integral dz is z, 0 to 12 minus 2x minus 3y by 4 dy dx. Now substitute the limit, x is 0 to 6, y is 0 to 12 minus 3x by 3, 12 minus 2x minus 3y by 4 dy dx. Let's like our previous problem. Now integrate with respect to y, then integrate with respect to x. You will get total final answer is 12. The remaining part is homework for you. You can try at home. Okay. Now we will discuss another problem. Now another problem. Evaluate triple integral x, y, z, dx, dy, dz over the positive octant of the sphere x square plus y square plus z square equals to a square. As in the earlier class we discussed a similar problem, same problem with numerical difference. Positive octant. In three-dimensional geometry, the region between three coordinate axes, xy plane, yz plane, zx plane is nothing but the positive octet. Now sphere x square plus y square plus z square equals to a square. It represents a sphere. Sphere in positive octet. This is the region. Now then, how to find the limits? Solution. Already we discussed in the earlier problem. X, Y, Z limits. X, Y, Z, dz, dy, dx. Now limits. Along, I will take Z here. Very simple. Take anyone, it does not matter. Along the axis, here z equals to 0, xy plane, z equals to 0, 0, 0, 0, z equals to 0 to this sphere equation. What is the sphere equation? X square plus y square plus z square equals to a square. Lower limit is in positive octet, all lower limits are zeros between the three coordinate axes. From this one, z equals to square root of a square minus x square minus y square. So upper limit is root of a square minus x square minus y square. Now finding the y limits. Now y limits means along y axis in two-dimensional methodology. From this origin to this circular curve. So remove z, circular curve. From this one, y equals to root over a square minus x square. Root over a square minus x square. For finding the x limits, now remove y, x square equals to a, x equals to a is nothing but this is a, radius is a. Along x axis, here 0 to a. Now integrate with respect to z, then integrate with respect to y, then integrate with respect to x. Like our previous problem, 0 to a. Y is 0 to root over a square minus x square. Integral z is z square by 2. Now 0 to root over a square minus x square minus y square dy by dx. Now put z equal, now 1 by 2 is a common term. If we common 1 by 2. Y is 0 to root over a square minus x square. X into y into z square is nothing but root over a square minus x square minus y square whole square is nothing but a square minus x square minus y square. If you put that equals to 0, 0, dy by dx. Now integrate with respect to y, then integrate with respect to x. Now continuation, 1 by 2 times of integral 0 to a, integral y is 0 to root over a square minus x square, x into, x is already constant, y into this term, y into a square minus x square, y into y, a square y cube, dy dx. Now integrating with respect to y. 1 by 2, x is 0 to a, integration with respect to y, x into, y integration is y square by 2, a square minus x square into y square by 2, y cube integration is y power 4 by 4. Yes. 0 to root over a square minus x square dx. Now substitute the limit for y equals to square root of a square minus x square, then what happens? 1 by 2 integral x is 0 to a, x into a square minus x square by 2, y square, y is root over a square minus x square, whole square is nothing but a square minus x square. Fine. Root over a square minus x square whole power 4 is nothing but whole square is nothing but square and root cancel. A square minus x square whole square by 4. If you put y equals to 0, this is 0, this is 0, dx. Now, if you observe a square minus x square, a square minus x square, so both the terms are same, common the term, 1 by 2, x is 0 to a, x into a square minus x square whole square, 1 by 2 minus 1 by 4 dx. Now, if you put a square minus x square equals to t, a square minus x square equals to t, minus 2x dx equals to dt, x dx equals to dt by minus 2. So, using this one, what happened? 1 by 2. Now, observe. X into dx. This is 1 by 2 minus 1 by 4 is nothing but 1 by 4. Okay. X dx is nothing but dt by minus 2. Okay, fine. This is t. A square minus x square is a t square. T square integration is minus 1 by 2 into t cube by 3. So t is nothing but a square minus x square. A square minus x square whole cube by minus 2 into minus 3 minus 6. 0 to 8. So 8 6 are 48. 1 by 48. Okay. If you put x equals to a square minus a square is 0. Minus or minus plus. If you put x equals to 0, a square whole cube is a power 6. So your answer is a power 6 by 48.